Turning in a brief, Cimatron 15. Cimatron 15 features a new turning application. This movie will show a quick preview of how it looks like. The first thing which is important with turning in Cimatron 15 is the NC setup. We are using GIPSCAM as a background engine to calculate the turning motions. For calculating the turning motions, GIPSCAM need the machine configuration. The machine configuration is being set here in this new parameter, which is called turning configuration. When you load the machine, it will automatically load the turning configuration file, which is kept in the same folder as the machine. Another important thing to understand about turning is that the reference UCS must be on the turning axis, on the axis around which the part is rotating. If I show the machine, I can see the part located on the center of the spindle as it should be for turning. So back to the NC setup, we must use it because this is the only place where we can define the turning configuration file. The part procedures go as usual under the NC setup. We have our part, we have the chuck, which is defined as a fixture. Stock also goes under the NC setup. For stock, we added a new option, revolve. It was created especially for turning, but can be used later on for milling. Under revolve, we have 4 revolved types: cylinder, bounding cylinder, revolved contours, and revolved set of surfaces. We will use the cylinder in this case. 3 new views were added, especially for turning. First is a lathe front view. It positions the part as it should be on a lathe with the Z-axis pointing to the right and X-axis pointing up. The next one is an isometric lathe view. And the third one is a lathe section. It cuts the part in half exactly on the XZ plane, and it acts as a toggle. You either turn it on or off. In the TP folder, there is a new cylindrical clearance. It is only available if a turning configuration file was set in the NC setup. This clearance is used as a default clearance for the turning procedures. Turning cutters are different from the milling ones, both in look and definition parameters, which is why they are handled in a separate dialog. The dialog is open from here. Its overall layout is very similar to the milling cutters dialog, yet the parameters are different. The definition and editing of the turning cutters is done via a GIPSCAM dialog. Details about how to do that exactly will be discussed later on. To define a turning procedure, the main selection needs to be set as turning. If a turning configuration file was not defined, an error will pop up telling that it is not defined and that turning cannot be activated. The 5 sub-selection options that we have under turning are rough, volute turn, contour, thread, and lathe drill. At this point, we'll select rough. The only geometry needed for a turning procedure is a single open contour. Indeed, this is the only selection option. In the first turning procedure, when you click on the contour selection button, what you see is the following. The pink figure is what is called the span silhouette contour. It is derived from the section of the rotating part with the ZX plane, which is the turning plane. The span silhouette contour is in fact closed, but it has 2 points, a start point and an end point, which are located on the extreme points. These points actually define a portion of this closed contour, which in fact makes it an open contour for turning. On the start point, you can see the big arrow, which indicates the milling side. It points outside, as this is the only way that turning is possible. The smaller arrow shows the cutting direction. In fact, it shows the side of the span contour, which is selected for turning. There is the option to flick milling portion. Okay, you can see that the small arrow points to the other side. That means that the turning will be done in the inner diameter of the geometry. There is another button to flip between the start and end points. This controls the main cutting direction. And since this is not the real or the full length of the contour that needs to be machined, it is possible to change by modifying start points and selecting a different point on the contour. The start point is changing, and the same can be done for the end point. Possible also to add extension, like 5 millimeter at the beginning and 5 millimeter at the end. Notice that the arrows are shifting to the extension endpoints. By that, the contour selection is basically finished. We can close and save. For the next turning procedure, if you open the contour selection, it will inherit the selection from the previous procedure. So you can either reset or modify according to what is selected at the moment. There is another option which is called manual selection. If you select it, then you will get a minimized contour manager dialog, which enables the selection of one contour. Through this way, you can select predefined curves or composite curves that exist in this file. For cutter selection, again, the turning cutters dialog is opened, where you can select a predefined cutter or create a new one on the fly. We'll use the single cutter which exists at the moment. In the motion parameters, first of all, in the clearance and UCS, there is a new parameter which is a XD clearance. This is the diameter clearance that we've seen in the TP folder with the default value of 200. Of course, it can be changed per procedure. Under tool trajectory, the only thing that we see is an access button, which when clicked, opens a GIBSCAM procedure dialog. The first thing to notice in the GIBSCAM procedure dialog are the cut options. It is a rough procedure, but here you select whether you rough the outside, the internal diameter, the front face, or the back face. On the right, we have the clearance diagram, which also changes according to the cut options. Here is where we set the procedure entry and exit clearance values and the initial stock diameter. These are diameter values. This is what XD stands for. Just underneath, there is a setting of the rough style. Full means that the procedure is not considering the stock, which is why we have to give the initial diameter of the stock. If set as material only, then the procedure is supposed to consider the previous stock and the initial stock diameter parameter disappears. Rest of the parameters actually depend on the procedure which is selected on sub-selection. For rough, this is the parameters that we see. For contour, threading, volute turn, and other options, there is another set of parameters. For now, let's set a minimum of 2 millimeter cut depth and leave an offset of 0.2 millimeters on the part. The next page is called the rotate page. This is where you set the holder angle in reference to the stock or the rotary axis. This is the blue is the z-axis, the red is the x-axis of the machine. When the machine is reset, the tool is parallel to the part and not a suitable orientation for turning. We need it to be 90 degrees, and this is how we set it. The other two parameters are informative only. They show the face relief, which is the angle of the insert to the face, and the diameter relief, which is the angle of the insert to the diameter. These two values take into account the holder angle, the insert tip angle, and the orientation of the insert on the holder. Back to the procedure grid. In the machine parameters, we have an option to select between constant spin, which is given as revolutions per minute, and constant surface speed, which is given as meters per minute, as required sometimes for turning. This is where you set the spin, and this is where you set a limit, as with this option the spin gets higher as long as the diameter gets smaller. Now, since the setting is finished, we can calculate the procedure. This is what we see as a result, a multi-layer rough procedure over the length of the contour which was selected. Notice that the stock is being updated the same way as it does with milling, so that it will be available for the following procedures: turning or milling. The navigator looks, feels, and behaves exactly the same way. We have the movie mode. You can run by block and follow the motions with the tool. One thing to realize here is that the motions are always drawn at the middle of the insert tip radius. Now let us start a new procedure, and this time the sub-selection will be lathe drill. Notice that there is no point selection in the lathe drill, as lathe drill can only drill the center of the rotating part. The selection of the tool, although it is a lathe drill, is done in the milling cutter table. We'll select this one. There is no access button to refer to GIPSCAM. We're not using GIPSCAM for lathe drilling. It is all done in Cimatron. Let's select a deep hole pack, activate the packing, 10 millimeters deep each. The Z values, clearance 50, delta Z fit start 3 millimeters, and depth minus 155. All the parameters are really familiar from the legacy drill, and overall it is really straightforward. We'll calculate the procedure, and that's it. Let us navigate the drilling procedure. Since the work is done on the inside, it is better to use the last section view to really see what is going on. As for the simulation, we will simulate both procedures. and use the machine simulation. Okay, once again, this is the same familiar environment, same functionality, same behavior, everything is exactly the same. You can show the motions, hide the motions, and let's run the movie mode. Tool change. Okay, again, we can use the cut section view and see exactly what has become of the part in stock. Again, this is my fixture, this is my part, and everything is exactly the same as we know from milling. This has been a short introduction for the turning in Cimatron 15. Thank you for watching.